Okay, so we'll be getting started now. Today we'll be going over multivariable expressions and how they contrast from the single variable counterparts. So we've gone over our one variable, so like x, which can be attributed to a value like 3, but its basis is that it's a variable, it's something you need to find or need to substitute in. Now that we've got that down, we now have a second variable, say y, or sometimes r and s, sometimes are a duo, but for now x and y. This helps us with more complex problems that have 2 or more values that need to be set. So let's say if x equals 3 and y equals 5, then the expression x plus y would be 3 substitute into x substitute into 3 and 5 would be 8. But when we were going over single variable, we went over the concept of like terms, which are terms with variables to the same power. This is similar with more than one variable, since you can have, since x squared y is the same like term as y, x squared y times 3. However, this and this are not the same variable, not like terms. Y with x squared y is not like terms with y squared x. And this 3, as we did before, is a coefficient. So foremost, we need to know how to evaluate these expressions. So if we had x squared plus y times x, if we had x equals -3, y equals 5, then we could substitute this in. -3 squared plus 5 times -3 equals 9 plus -15, -6. Now, if we had these same values, what would x minus y squared plus x plus y squared equal? Answer in the chat, preferably privately. Yes, that's correct. That 68. Since -3 minus 5 equals 8, -8, and -8 squared is 64, and this turns out to be 4. Now that that's covered, we now need to simplify these multivariable expressions. So we have a few ways we could simplify. So one way is combining like terms, as I discussed before. So if we had an equation such as 3x minus 4y plus z, which is a third variable, and x the same way as the other two, minus 2 plus 5x plus 3y minus 2z, then we have to combine like variables. So these two are like terms. Did I say like variables? I meant like terms. These two are like terms, and these two are like terms. So 3x plus 5x is 8x, minus 4y plus 3y is minus y, plus z minus 2z is minus z, and minus 2 doesn't have a like term, so it's just minus 2. This is useful when you don't have the values of x, y, or z, since they would still be unknown and cannot be cancelled out or substitute into. As practice, 3a times b minus 4cd plus 3 over 2 plus 2cd minus ab over 2 plus 3 plus 2 minus ab. What does this expression simplify into? As I've discussed before, you need to find like terms. Okay, so 3ab and negative ab over 2 are like terms, so it's cd. All these constants, 2 net plus 3 over 2 plus 3, are also like terms since they're just constants. We could remove these parentheses since everything gets added up anyways. So now we have 3ab minus 4cd plus 3 over 2 plus 2cd minus ab over 2 plus 3 plus 2 minus ab. Now, so these three are like terms. 3 plus -1, -half, I mean, plus -1 is 3/2, -4, or +2 is -2. 3 or halves plus 3 plus 2 is equals to 13/2. This is similar what we've done with one variable. It's just applied to multi-variables. Does anyone have any questions? Another thing we have to simplify is if the variables are multiplied with each other. If you need me to review something, please say what part to review. So as we gone before, a squared, where a is a variable, equals a times a. Reviewing the reviewing the problem before, we had 3ab minus 4cd plus 3/2 plus 2cd minus ab/2 plus 3 plus 2 minus ab. Put simply, we could add these three together, these three together, and these two together, because these groups are like terms, and so you would find the final answer. Moving on. So a squared is a times a. So similarly, if you had something like a times b times a times b, first off, this part is a squared. This part then forms a squared times b. But then you have this a here. So it's a squared times b times a. But since multiplication is, because order doesn't matter, multiplication, we can times these two together to form a3, and these two to form b squared. Another thing we would have to do is say x squared minus 5 is x10, since the one exponentiating an exponent, the powers, which is the top part, multiply. Now, if we had something like ax squared times 10, and this would equal a 10 times x squared. 10 equals a 10 times a 2 times 10, which is 20. So a to the 10 and x to the 20th. This would carry on if we had, say, a 2 here. So this gets a 2 times 10, which is 1024. As we gone over exponentiating variables with more than one variable, similarly, we could do radical, since exponentiating is using a radical is basically the exponentiating. So square root 3 a6 b12 times 27. So we could make this into a6 times b12 times 27 to the 1/3, since radicalizing by, say, 3 is exponentiating by 1/3. So this equals, by this is pattern, we have a6 1/3 plus b12 1/3, no, times 27 1/3. Now 27 is 3 to the 3rd, so this becomes 3 since it has a 1/3 on top. 3 times 1/3 is 1. 12 times 1/3 is 4, so a6 times 1/3 is 2, so a2 times b4 times 3 is our final simplification of this expression. Another thing we have to worry about is fraction. So as I said before, during our one variable expression lesson, if we had a fraction with the top part is the numerator, denominator is the bottom. If we had, say, 5 times 7, 7 times x on the top, times 9, then we can cross out common factors on both the numerator and the denominator. Now, if we have, say, multivariable, so like 7xy over 9x squared y squared, the same thing applies. Both the denominator and the numerator share common factor of xy. So you can cross out an xy here and then an xy here. I'm crossing out the power since x squared y squared divided by xy equals xy. So this forms into 7 over 9xy. Now that we've gone over that, what is 15x plus y times y over x plus y squared times x. What does this simplify down to? Okay, so each side of this has x plus y as a denominator. So you divide this from this, which causes up this from this expression, which causes up one of the powers. So the final answer is 15y over x plus y over x. You could distribute this further, but there's not too much point. Yes, that's correct. So this could, I'll explain distribution just in the, I'll explain distribution right now, actually. So as I've gone over before, or can the y, the denominator, and the y, like the fraction here? No, because this isn't a common factor between these two. If we had a y divided out from the denominator, then it would be this. And we would have another fraction, which isn't good. So distribution and factoring. So I've gone over this on the one variable. So x distributes into each term 7 times x, x times x, 7x, and x squared. Similarly, if we had the expression we had just now, x times x plus y, this multiplies into this. This multiplies into that. Many of these simplifications use similar concepts. So x times x is x squared, x times y is xy. Now factoring, so in a similar way, if we had 7x plus 15x squared, this would simplify to x7 plus 15x, since these two share x as a factor. Now, if we had 8x y squared plus 15x squared y, then because these two share xy as a factor, xy can be divided into each of these terms without it becoming a fraction. Then we could take this out of the expression, as you say, and write the quotients into the box, the parentheses. These, if you check, you can multiply this into each term and get the original. Does anyone have any questions? Okay, so this is a more challenging problem, but if we had x plus 7, y minus 4, how could one distribute this? So no more parentheses left over. So yeah, so we have these two. I don't know what FOIL is, but regardless.
It's a formula.
Regardless, we can split these, turn it into x, y minus 4 plus 7, y minus 4. If it works, I don't really care what you use. So this distributes, so we have xy minus 4x plus 7y minus 28. The thing about FOIL though is that if we had something like x plus y minus 3 over x plus y, it doesn't really work. So you're just better off doing a multiplication thing where you just do multiplication, except it's variables instead of numbers. So each pair across these two lines are multiplied. So x times x, x squared, y times x, yx, x negative 3, negative 3x, xy y squared minus 3y, you get the point. So this is also similar to how we did with usual fractions. So like x plus 3 plus 5 over x. You need to find the common multiple between this, or you could just multiply them together and then simplify the fraction. Either way works. So x squared plus 5x plus 15 over x squared plus 3x. You get them. But if we had, say, say 2 over r plus 3 over s, then you multiply these two together, rs 2s plus 3r, and then also multiply these two cross. And then check for a common factor, which there isn't in this case. We'll cross multiply in that 2 multiplies with s, r times with 3. And if there was a third fraction, z, then 2 would times with s and z. So, and the bottom would be s times the product of the denominators. 3 would times with r and z, 4 times with r and s. So 2sc plus 3rz plus 4rs. If there were like terms, I mean a common factor, we would cancel it out, but there aren't. So let's say we had 3 fractions in a single expression. So 2a cubed over a cubed b plus 3b over a minus 1 plus 3b minus 3 over 6ab minus 6a. Okay, so first off, if you notice here, we have to simplify like the fractions themselves since they have common factors. So this fraction has a cubed in both the numerator and the denominator, so they can be crossed out. This one does not have any common factors, so we can leave it. This one has a common factor of 3, so this can be crossed out into b minus 1, 2ab minus 2a, and it has a common factor of b minus 1, so that crosses out further into 1 over 2a. So the new expression would be 2 over b plus 3b a minus 1 plus 1 over 2a. So we do the same thing before where we multiply denominators and do this with cross thing where each numerator gets multiplied by 2 other denominators. So, well, a better way to think of it is the new denominator being one of the numerators being multiplied by a new denominator, which is the mass product of these denominators over its original denominator. So 2a minus 1a plus 3b times b times 2a no, that's not this. B times a minus 1. I'll erase all of this so we have space. So we then distribute, so a distributes onto 2a actually distributes onto a minus 1, so 2a squared minus 2a plus b times b is b squared, 2a gets multiplied in there. Also, letters in the alphabet should come first in multiplication, in products. B distributes onto a minus 1, ab minus b, and down here, b multiplies by 2a and then distributes onto a minus 1, so 2a squared, b minus 2ab. And we would combine like terms up here, but there are none. No, sorry, there should be a 2a here, and there should be 4. But everything else is good. Any questions on that? So now we have hold on a second. Okay, so we had equations for single variable equations before, like x plus 3 equals 5, so x is 2. Now if we had more than one variable, like a plus b equals 6, then, well, we can't solve this equation since both a and b are not constants. If we can't really solve what they are, but we could solve what they are in terms of something else. So for example, a equals 6 minus b after we minus b from both sides. Writing it like this is writing A in terms of B. Similarly, if we had x plus b equals c minus bx equals c minus b, this would be writing x in terms of c and b. Now that we have that, what is write x in terms of c and a?
R equal R minus R.
What?
MVM.
Could you type in the chat? I can't really tell what you're trying to say. So we need x on one side of the equation. That is correct, but we moved on to another problem. So we need x on one side of the equation to equal some sort of expression. So we need to divide a on both sides, so x equals c over a, which is the final solution for this in term. So let's say we had ax plus bc equals 3c minus 2dx d squared. If we had to write x as write x in terms of all the other variables, so we need x on one side of the equation. So there's an x here and an x here, so we need to shift this on one side of the equation and or the other. This side's positive, so it's more convenient to move it left. So ax plus 2d squared x plus bc equals 3c. Now that we have x's on this side, we need to factor x so that it's x times something that acts as a coefficient. So x a plus 2d squared, since they have a common factor, plus bc equals 3c. So now we can shift bc over and then divide by a plus 2d squared to get our x in terms of all the other variables.